All right, welcome back. Algebra 1. Here we go, section 8 today. We are still factoring. All right, I know we've been factoring since section 6, but we are now working with what's called special products. All right, so we are still factoring trinomials, but we are looking for these trinomials to have some specific traits. And if they have these traits, they're going to fit into these categories where they are called a perfect binomial or a perfect trinomial. Okay, and if they are, then they actually factor very easily. Okay, so what you want to take the time to do is just this. Is it a perfect square binomial? This is how you test it. Look at the first term, and that must be a perfect square. If it is, move on. Look at the second term. That must be a perfect square. All right, and then if that is a perfect square, then the final piece you're looking for is the sign between those two terms must be subtraction. Okay, so again, first term is a perfect square. Second term is also a perfect square, and it's key that it is subtraction that is between those two terms. All right, so let's zone and zoom in right here. This is a perfect square. Y squared breaks down easily into y and y. 16 is a perfect square. That breaks down into 4 and 4, and it is subtraction. So if that is the case, then your perfect square binomial simply breaks down into this, y and y, 4 and 4, and it is always opposite signs. Pay attention to that. It's opposite signs in the double parentheses if you are factoring a perfect square binomial. Okay? All right. Now, what if it is a perfect square trinomial? All right, here's what you're looking for. You are looking for this. The first term is a perfect square. The third term is a perfect square. Pay close attention to that. It's the third term. And this second sign must be plus. If it fits those parameters, it is a perfect square trinomial. Again, first term, perfect. Third term, perfect. And the second sign must be plus. All right, here's an example of it. X squared is perfect. That breaks down into x and x. 9 is perfect. That breaks down into 3 and 3. And we have a plus sign. If that is the case, what this will break down into is that if they're both plus, you will now have this exact binomial written twice, x plus 3 and another x plus 3, because they were both plus. Now, if this is plus, and we double check that that is a perfect square, and that is a perfect square, but the first sign is a minus, then both parentheses will be minus, all right? And they'll still be perfect squares. In this case, 25 breaks down to 5, x squared breaks down into x, all right? So you're looking for it to meet the specific criteria that I just said. So again, if it's a perfect square binomial, first term is perfect, second term is perfect, and it must be subtraction. Okay, if we're looking at a trinomial, first term is perfect, third term is perfect, and the second sign has to be a plus sign. All right. So again, in these videos, you could pause it, you could rewind it, you can copy all that down. You should be doing all of that. All right, let's do our example problems. We just have 4 of them today. So here we go. First one, let's check to see x squared is perfect. The number 4 is perfect, and it is a plus sign. For this trinomial, then I'm looking, if this is plus and this is plus, then here's what our double set of parentheses will be, both plus. X, 2, and 2. Now in the textbook, you may notice they will be writing their answers x plus 2, but that is quantity squared. Why is that? Because I have 2 identical binomials. So I could just say, do that binomial, but it's twice. Okay? All right, let's take a look at our second example. There's something important that you should notice here. Always, always, always check if you can factor something out. Because if you can factor something out at the beginning, it will make the rest of the problem easier along the way. Here's what I'm talking about there. 18, 12, and 2. They all share a number. 18, 12, and 2 all share a number. What number is that? The number 2. If we factor out a 2, this becomes 9x squared plus 6x plus 1. Now, if you look closely, we meet the parameters of a perfect square trinomial. 9 is perfect. 1 is perfect. And we have a plus sign right here. All of those meet the parameters for a perfect square trinomial. So still that 2 is on the outside and has to stay there. Then the 9 breaks down into 3 and 3. X breaks down into x and x, double plus signs. And 1 is a perfect square because the square root of 1 is 1. So this is it right here. Or you could write 2 parentheses 3x plus 1 squared. All right, let's do our next one. Let's pay close attention. We can't factor anything out. But just because we have another variable and it's squared doesn't mean that anything changes. All right, x squared is perfect. 36 is perfect. Y squared is perfect. And the second sign is plus. It still meets all of the same parameters. All right, I've said it many times. We got to just keep practicing these problems because you may ask yourself, how am I ever going to see that? Through practice and repetition. Look for these special things each time. All right, so when we break this down, this is going to break down into a double set of parentheses. Okay, just like we've always been doing. Then we have an x and another x. We're going to have a plus sign and another plus sign. And 36 is going to break down into 6 and 6. And the y squared is going to just break down into y and y. And in that case right there, it still fits those parameters of a perfect square trinomial. Okay, right there, that fits. And we finish that one out. All right, last one here. It's asking us to solve it. This is a binomial. So let's remember the qualifications to make it a perfect square binomial. This has to be perfect. The second term has to be perfect. And we have to have a minus sign. So this means it is a perfect square binomial. And those parameters mean I still use double parentheses. All right. Break it down right here and right here. But remember, for a binomial, the signs are opposite on the inside. All right. And the square root of 81, is 9. So put 9 in both of those. And it's still saying equals 0. Okay? But now because it says solve, just set each of these equal to 0, like we've done in class. All right? So x plus 9 equals 0. X minus 9 equals 0. Solving each of these, you get a negative 9, and you get a positive 9. All right. There you go, guys. That covers our video. There are the 4 example problems right there for section 8. Good work. Keep working hard. Ask those questions. And make sure that you are taking diligent, strong notes. All right, guys. I will see you in the next video.